Hello, everyone, and welcome back. Today we're working with TEAC G2A, skill number 5. And so our objective is to use the midpoint formula to calculate missing coordinates on a line segment. And we're going to be looking at this in the coordinate plane. So we're going to be using horizontal and vertical distances. Your success criteria reads, I can use the midpoint formula to calculate missing coordinates on a line segment. So what this looks like is they're going to give you a midpoint and they're going to give you an endpoint. And what you have to do is you have to find the coordinates of that other endpoint based upon the midpoint and the endpoint that they gave you. And so the problem looks something like this. Find the coordinates of M if n, 3, -5 is your midpoint. It's the midpoint of MO, and O has the coordinates of 6, -9. So what I did was I just graphed this so that we could get a better idea of what it looks like. And so we know that N is our midpoint. And we know that O is one of our endpoints. And so this could be our X2 and our y2. We could have made it x1, y1, but I just put x2, y2. So what they're asking us to do is they want us to find the missing endpoint of this line segment that is maybe somewhere around there, and this is going to be point M, and this will be our x1 and our y1. Now you know since n is the midpoint that these two segments have to be congruent. So our task is to find the coordinates of M, and there is a process that we can use to do that. The process is this. One, we substitute the information that we're given into the midpoint formula, and I wrote that out to be M is equal to x1 plus x2 divided by 2, or y1 plus y2 divided by 2 as well. And then we write two equations to find the coordinates of M, and then we solve those equations. So let's start by doing step 1, which is substituting the information. My midpoint is 3, -5, so I'm going to write 3, -5, and I know that's going to be equal to the x1 plus the x2. I don't know what x1 is. I'm looking for it, so I'm going to write x1, and x2 is 6, and that's all divided by 2. And then my y portion would be y plus a -9 divided by 2. Now, this right here, this 3, goes with the x1 plus 6 over 2. The -5 right here goes with the y plus -9 all over 2. And so when we break up these coordinates, we're going to break them up into two equations. The x goes with the x and the y goes with the y. So my 3 is going to be equal to x1 plus 6 all over 2, and my y will be -5 equals y1 plus a -9 all over 2. I'm going to start with my x1 first. So I'm going to get rid of this 2 that's in the denominator so that I don't have to work with fractions. The way I do that is I multiply both sides by 2. I'm going to multiply the left side by 2 and the right side by 2. The 2's cross out on the right-hand side, and I get 6 is equal to x1 plus 6. I want to get these x1's by themselves, so I need to get rid of the positive 6. The opposite of adding 6 is subtracting 6. So I am going to subtract 6 from both sides. What happens is, notice on the left-hand side the 6's cross out, and notice on the right-hand side the 6's cross out. And so what we get on the left-hand side is 0, and what we get on the right is x1. I'm going to flip it around and say that x1 is equal to 0. So we have our x coordinate for that endpoint M. I'm going to come over here, and we're now going to start with our y's. I'm going to do the same thing. I'm going to multiply both sides by 2 because I want to get rid of that denominator. So I get y1 plus a negative 9 all over 2. And on the left-hand side, I get a negative 10. The 2's cross out, and what remains is y1 plus a negative 9. Now you know that if we're adding negative 9, we can just turn that into a subtraction problem, and this becomes y1 minus 9. So I want to get the y1's by themselves. In order to do that, if we're subtracting 9, I need to add 9 to the right and add 9 to the left. So I'm going to take my negative 10, add 9, and I am going to add 9 to the right. These cross out. On the right-hand side, I get y1. On the left-hand side, I get a negative 1. So I'm just going to flip it to read y1 equals negative 1. I'm going to take this x1 and my y1 here. I'm going to bring them down, and the end point, which is m, is going to be 0, negative 1. If I go back up to my graph, I didn't go far enough. It's going to be right here. So that's where m is going to be. So we found the coordinates of our endpoint to be 0, negative 1. Let's use that same process on another example. So the example reads, find the coordinates of A if B, which is 2.6, 3.5, is the midpoint of AC, and C has the coordinates of 4.7 and a negative 8.1. And so what I'm going to do is, just so that we can visualize this, I'm going to draw a line segment. And what we're looking at is we have A, we have C, and then B is our midpoint. And so that's what it should look like, something like this. I don't know if it's facing in the right direction. I'm just drawing it to get a visual. And so I know that C has the coordinates of 4.7 and a negative 8.1. I know that B, which is our midpoint, is 2.6 and 3.5. And so I'm looking for A, which is going to be my x1 and my y1. So this will be my x2 and my y2. We're going to follow that same process that we did in the prior example. We're going to take our midpoint formula, which is m is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2, and we're going to substitute the information that we know. We know that B, which is our midpoint, is 2.6, comma 3.5. And that's going to be equal to, we don't know what x1 is, so I'm leaving that as my variable. I'm going to add it to x2, which is 4.7. I'm going to divide it by 2. I'm going to do my y's. I have y1. I'm going to add it to my y2, which is a negative 8.1. And I'm going to divide that by 2. If we look, we know that our 2.6 goes with the x plus 4.7 over 2. And we know that this 3.5 goes with this over here. And so we're going to separate it into two equations, and we're going to solve. So I'm going to get my 2.6 is going to be equal to x1 plus 4.7 divided by 2. And my 3.5 is going to be equal to y1 plus a negative 8.1 all divided by 2. Now, the thing that makes this a little more challenging is that we're actually using decimals, but that is not going to be a problem. You can do this, okay? So what we're going to do is we're going to multiply both sides by 2, and we're going to work with that x equation first. So I'm going to go 2.6 times 2 is going to be equal to 2 times x1 plus 4.7 divided by 2. So I know that 2.6 times 2 is 5.2. The 2's cross out here. I get x1 plus 4.7. I want to get these x1's by themselves. So what I'm going to have to do, I'm going to have to subtract 4.7 from the right and 4.7 from the left. So I'm going to write that step out. It is 5.2 minus 4.7 is equal to x1 plus 4.7 minus 4.7. These cross out, and 5.2 minus 4.7 is 0.5. So my x1 coordinate is 0.5. I'm going to flip it around, and it's going to be x1 equals 0.5. I'm done with the x's. Now I'm going to move to the y's. I'm going to do the exact same thing, that exact same process that I used on the left side. I'm going to use it over here. So I'm going to take and multiply both sides by 2 because I want to get rid of that denominator. So I get 2 times y1 plus a negative 8.1. And all of this is going to be over 2. 3.5 times 2 is 7. The 2's cross out, and I get y1 plus a negative 8.1. Now notice, I want to get the y1's by themselves. In order to do that, I'm going to rewrite this so that it just makes a bit of sense, knowing that if we're adding a negative, all we have to do is subtract it. And so now it makes it a little bit easier to see what we have to do, because we know that we're taking 8.1 away from y1. So in order to get y1 by itself, what we have to do is we're going to have to add 8.1. And if we add it to the right side, we have to add it to the left. So that's exactly what I'm going to do. 7.0 plus 8.1 is equal to y1 minus 8.1 plus 8.1. The 8.1's cross out, and what I'm left with on the left side is going to be 15.1 is equal to y1. I'm going to flip that around and say y1 equals 15.1, and I'm going to take my x's and my y's, and I'm going to put them together. And we are looking for, remember, we're looking for A. So the coordinates of A are going to be 0.5 and 15.1. That's the end point of this line segment. My friends, way to go. Now, take what you've learned and make it happen with those practice problems. I know you're ready. Have a great day.